Hey folks, this is Dr. Scott Duncan, and we're in the middle of Class 12, Evolution 4, and we're about to start Part 2, where we're going to explore the Cambrian period all the way to the Devonian period. These are periods of the what's known as the Paleozoic. So here's our timeline. Remember, let me get my laser pointer going on here. Remember that we started in the last section, we started with the Hadean down here at the lower right, and then we zoomed through like several billion years worth of time and ended at the end of the we ended at the end of the Proterozoic eon here. And then we're going to pick up right now where this big old red star is here at the beginning of the Paleozoic. We're going to cover in this section here the Paleozoic and all of these periods that are in this zone here that you see from the Cambrian all the way up to the Permian. Some pretty exciting things happen to the planet during this time period that wind up affecting our lives and affecting Alabama today. So let's get started. Now, one of the things that we'll see as we are exploring how Earth changed during this time period and in later time periods as well is that the changes in continent position on the surface of the planet, whether they were near the poles, near the equator, or whatever, that would wind up shifting some things. It would wind up affecting things like sea level. We'd see that sea level would rise and fall depending on several factors that we'll go over in a few minutes. It would also wind up affecting ocean currents, like whether those currents are able to travel freely across the Earth's oceans, or if they get interrupted by a current or bent. I'm sorry, not interrupted by a current, but interrupted by a continent, or bent or curved in a different direction, diverted by a continent, these sorts of things. And then finally, we see climate vary for any particular piece of land over time as it moves across the surface of the planet. So all of these things are associated with change in continental position, are really influential for affecting what life is doing on that land. And of course, this is change that's happening over tens and tens of millions of years, so very incremental from a day-to-day perspective, but over long periods of time, very, very important. Okay, so the first of our periods we're going to look at is the Cambrian. This is particularly important because for the first time in the fossil record, we start to see a lot of really cool, larger organisms show up in the fossil record. These organisms, some of which we still find around today. In fact, most of the life, sorry about that, let's get rid of that. Most of the life forms that emerged most of the life forms that we find on Earth today, such as vertebrates and crustaceans and different types of worms and sponges and corals and things like that, they can all be traced back to this time period. They emerged during the roughly 40 million years of the Cambrian. And that grand emergence of so many different life forms where before we mostly had microbes is known as the Cambrian Explosion. All right, so one of the things that we see during the Cambrian is that there's lots and lots of rocks that were preserved during that time. So if you need a refresher on how rocks of different types form, go back to the first part of Class 12 when we to the notes on geology and some very basics of geology and how, in particular, sedimentary rocks are formed, because lots of sedimentary rocks were formed in the Cambrian. And I want you to think about this question for a minute. I'm going to pause the video. You should pause on your end and think about this and see if you can figure out the answer based on looking at your notes and the slides that we've covered so far. Okay, coming back from that pause, I hope that you've been able to figure out the answer to the question. And the answer to the question has to do with this point here, that we had a lot of erosion on the surface of the Earth and lots of deposition in the seas of all that eroded material, all that sand and mud that wound up being eroded off the continents, wound up in the oceans and became sedimentary rock. That sedimentary rock nicely preserved the fossils of all these organisms, and that's why we know so much about the Cambrian. Okay, now why is it that we had so much erosion going on in the Cambrian? Well, it's because there were no plants on land. So imagine if the landscape of the world was just rock and soil, and every time it rains, you get this flood of mud flying into the oceans, and of course, all that sediment settles out and ultimately became sedimentary rock. Okay, moving along here. This is a map of northeastern Alabama. You see Jefferson County right about here. This is where we are, right about the tip of that arrow there. And these orange colors that you see through here, those are rocks of today that date back to the Cambrian. And so that's one of the reasons why we've got so much cool geology in the state, is that we've got some really, really old rocks that go back a very long time ago. All right, those rocks would have stayed buried over geologic time, except when the Appalachian Mountains formed, they brought them up to the surface. We'll talk more about that in a few minutes. Okay, moving along here. So the next time period is called the Ordovician, and that lasted from about 505 to 438 million years ago. If you look over here to the right, you see the future location of Birmingham with that little red star, that little white star. And if you were to look over to what is today to the east, so over in Georgia, you had an emergence of some islands called the Taconic Mountains, and the islands associated with that, these were volcanic islands. Every once in a while, they would erupt and send a whole bunch of ash that would settle out over these oceans that covered up what modern-day Alabama is. We know this because we have rock that we can date back using radioisotopes, like we talked about in a previous class. We can date back to these periods, which is pretty cool. Now, what was going on in Alabama is that in this, where you see the lighter blue that I'm kind of outlining with my laser pointer here, this was very shallow ocean. And warm tropical waters that are shallow are going to support reefs. And we had lots of reefs formed in Alabama during that time period, with lots of cool critters like whatever these things are that are down here at the bottom, which I would hate to encounter if I was ever swimming out in the oceans. Switch my tools here. So we had these shallow seas. We've got reefs over Birmingham. And then this is the last part I want to make about the Ordovician, the limestone that was formed. Reef material, which is basically made of calcium carbonate, which is essentially the same as chalk, the same chalk that we use in the classroom. That reef material, when it turns into rock, it becomes limestone. And we have lots of limestone in Alabama that dates back to the Ordovician. As a result of these reefs being here at this time period. We also get lots of limestone from other time periods. This is not the only one. If we had had the ability to hike out at Rufter Mountain, we would have walked up and seen some of this limestone called the Chickamauga limestone. And that limestone is rich with fossils. We would have shown you some fossils like crinoids and a few other types of fossils that were around at the time. Okay, moving on, and here's our timeline down here at the lower right, showing you where we were here in the Ordovician. We're going to move next up into the, I already talked about the volcanoes and all that, so I'm going to blow past this. Let's next talk about the transition from the Ordovician to the next time period, the Silurian. This occurred as another supercontinent, this one called Gondwana. You see circled over here to the right. The Gondwana supercontinent drifted down to the bottom of the planet, as indicated by this big red arrow that you see down here. Now, what do you think would have happened as you now have some land that's near the poles, and in this case the South Pole? What could have happened to change the climate on the planet? I'm going to pause for just a minute, and you should pause too to think about the answer to that question. Okay, so if you spend a little time thinking about it, maybe you come up with the fact that, hey, today we've got a big chunk of land down at the bottom at the South Pole. Maybe ice accumulated there. And if that was where your thinking was headed, then you were in the right direction. In fact, let me see if I can knock this out right now. There we go. Okay, hopefully that'll disappear now. Okay, so with all that land at the bottom of the planet, that gives a chance for ice to accumulate. And the more ice that accumulates, the colder the climate gets. The colder the climate gets, the more ice that accumulates, and so forth and so on. So what we saw at the end of the Ordovician was that there was a lot of cooling on the planet. So a lot of landscapes and oceanscapes that were tropical became much more temperate, and some places even Arctic. And we think that that led to a mass extinction of species. Okay, so what is a mass extinction? Here we go, mass extinction. That is when we see the disappearance from the fossil record of a lot of life forms that had been present in earlier time periods. Mass extinction events there has to be enough extinctions to call it a mass extinction. This one certainly fits the criteria. 65% of species that were in the fossil record before the Silurian disappeared. So 65% of Ordovician life forms disappeared. That included 12% of families. Remember, families are the group of organisms right above genus. So you go from species to the next largest group, which is genus, to the next largest group, which are families. So when you lose an entire family, that's like losing all cats on the planet or all dogs on the planet. That's a lot of species. Okay, moving along here. This is an illustration showing the 5 major mass extinction events that have occurred in Earth's history, and I've listed over here on the left the times of those events, and basically
Hey everybody, welcome to
wow, I don't know what that is. Let me figure that out. Okay, I'm back. Sorry for that interruption. I'm learning how to screencast, and it's a learning curve, let me tell you. Okay, so what I was talking about was that we've got these 5 major mass extinction events, and I've listed some basic stats here and a little bit about what we know has occurred to cause those extinction events. One of the things that I want to point out is that we have some that are known for reasons that we think we know, like the Ice Age that we just talked about, different from the Ice Ages that have happened in just the last couple of million years. We'll talk more about that later. It also included things like asteroid impacts. Sometimes we've seen periods of intense volcanism, like lots and lots of volcanoes on the planet, that kind of thing. Sometimes asteroid impacts, again, show up later. So sometimes there's a bit of a mystery, as I indicate here, that there's, scientists are working with whatever clues they have from the rock record, and it's a difficult task, and it goes very slowly, but we're gradually piecing together Earth's history as our techniques get better and better. Okay, so let's move along here. The Silurian, which occurred after the Ordovician, lasted not quite as long, 438 to 416 million years ago. One of the things that I want you to know about the Silurian is that this is when plants begin to colonize land. They colonize areas next to the water at first, and then gradually develop the ability to go into ever more drier land as plants develop the ability to retain and hold on to their moisture and extract nutrients from the landscape without being immersed in water all the time. We see some of our first vertebrate ancestors appear during the Silurian, so the first primitive fishes emerge. And we also see a lot of the first land animals in terms of invertebrates. So things are starting to happen on land for the first time during the Silurian. Now, the Silurian actually has a lot of importance for us because it was during that time period where in the area that is now north central Alabama, there was a shallow sea, and the sediments in that ocean had a lot of iron in them. And the sedimentary rock that formed during the time period is called the Red Mountain Formation, and the particular mineral that was formed is called hematite. You might recognize the root of that word, hema, like hema, of course, is the same root as hemoglobin, referring to iron. And in fact, these rocks are quite red in formation. Hence the name of our nearby mountain here next to the campus across on the other side of Birmingham is called the Red Mountain Formation. And our mountain's called Red Mountain. Okay, so it's all that iron that's in these sedimentary rocks that gives it that reddish coloration, because when it rusts, essentially when it oxidizes, it gets that reddish coloration. Okay, now the cool thing is, I think it's cool anyway in my geeky sort of way, is that this rock, if it hadn't formed, there wouldn't be all this rich iron material in the Birmingham area. And if there hadn't been the iron ore here, hematite is the same thing as iron ore. If we hadn't had all that iron ore, then Birmingham would not have established. Birmingham was established in 1872 because of the mining of that iron ore and turning it into pig iron as well as steel. And that's led to the birth of Birmingham. So we wouldn't be having this conversation today if it wasn't for events that we can trace all the way back to the Silurian. I think that's pretty cool. Okay, moving on, the Devonian, our next period in the Paleozoic. What was happening during the Devonian is that advanced land plants start spreading over the landscape. You have more and more land animals that are following the plants. Wherever plants go, animals are going to follow. We see the first land vertebrates, the first amphibians. So the fishes essentially were learning to exploit all sorts of different ecosystems, and some of them were exploiting these kind of near-shore environments and developing characteristics that allowed them to occasionally come out of the water and onto land. We've got several species of fish that do that today that are kind of indications of what those early organisms looked like. And we believe that was the transition to land from fishes to amphibians, where we saw the first amphibian species, like these little weird-looking guys we see pictured over here on the right, beginning to emerge and show up in the fossil record here. Okay, so from the end of the Devonian is marked by our second mass extinction period, which is another great loss of many, many species as seen in their disappearance from the fossil record. Okay, that ends part 2 of our exploration of deep time. We'll pick up on part 3 in just, well, for me, just a moment, but for you, whenever you click on part 3.